Hello everyone and welcome back to Diksha Karnataka YouTube channel. I am back with the third part of basic mathematics for physics. In the previous two parts we have discussed about trigonometry and also we have discussed about calculus. If you have not seen those, please check the pinned comment below and don't forget to watch those two videos. Those are very important, where I have discussed basic physics, basic requirement for those topics. Now today we are going to discuss about graphs. So what is a graph? We will start with graphs, basic graphs. Okay, then we will move to different types of graphs that we draw. It is not very unknown to you, but still, for example, let us start with something that you know, that is equation of a straight line. So if I give you a straight line, how does a straight line looks like? A straight line looks like this: 5x plus 2y equals to 3. This is an equation for straight line, right? You remember that. If you have remember, you used to plot this on a graph paper using this x, y, okay, 3 points. You find 3 points, then based on that there will be a graph paper, sheet of paper. You will take those 2 points. This is x, this is y, okay, and then you take these 3 points, then you draw a straight line. There was another straight line, and if you draw both of them, then you will find the intersection. So basically what is the meaning of this is, this thing represents a straight line. Any equation in the form of ax plus by plus is equal to c, or ax plus bx plus c equals to 0 is an example of a straight line. So this is a straight line, right? You already know that. Now if you take the c other side, it will be minus c. So basically a, b, c are constant. It can take any values. So when you are writing a equation like this is called a straight line. Basically what we are trying to do is writing an equation, then converting into a graph. So whenever a equation is given in mathematics, that corresponding equation can be drawn into a graph paper as a form of different kinds of lines. Okay, it can be a straight line, it can be curved line, based on whatever equation is given. So whenever a equation is given, you should know that that equation may be representing something in the xy plane. So and 3-dimensional equation as well, but we are not discussing 3-dimensional equation here. We are only discussing 2-dimensional equation, okay, that is x and y only. So when x and y are given, you can draw a straight line. Now this straight line can represent different things. This straight line can represent different things, and there are different way to represent a straight line. For example, another equation of a straight line is given by y equals to mx plus c. So those who have already completed the chapter straight line, they know that this is also an equation of straight line. And here this m is called slope, this c is called intersection. So if you draw this line, it will look like this. It will look like this. Okay, so what is m? If you take this angle theta, then m is equals to tan theta, and this distance is c. Okay, so those who have completed this chapter, they know this. I am not interested in all these things right now, but you should know that any equation that you can write in the form of ax plus bx plus c equals to 0, that is a straight line. You can write this as well. You can write this as a form of this same thing. So how can you write in this form? So mx minus y plus c equals to 0. So this can be written in this form, right? So basically any equation that can be written in this form, that is an equation of straight line, and that can be plotted as a straight line graph. So whenever you are seeing in physics, whenever you are seeing a equation like this, that is a straight line. For example, I am giving you one example that can be drawn into a straight line, that is a straight line graph. So if I give you one equation, v equals to u plus at, v equals to u plus at. So this is an equation of a straight line. Now how can we say that this is an equation of straight line? So v is basically y, okay, u is basically a constant c, and a is basically your slope m, and t is your x. So basically if you plot this line, okay, along x axis you plot time, along y axis you plot v, then you will get a graph like this. So basically this thing can be represented like using a straight line in the like this form, okay. So this is an expression equation of a straight line. So whenever a equation is given, if the power of x and y are only 1, then they are a straight line. If the power is other than 1, then they may not be a straight line. You have to simplify and check if the powers are 1 or not. There is a correction here. This will be y. This will be y. Okay, there is a correction here. This will be y. So if the powers of x and y are 1, then they can be written as they can be represented as a straight line. If their power are not 1, then we do not know what type of equation is this. Then we have to do the different kind of experiment with this. So you have understood what is a straight line. Straight line is basically when you write x and y like this and the power is 1. Power of x is 1, power of y is 1. Both of their powers are 1 only, not anything else. So you can write the equation like this, then they are called straight line. Straight line has a very huge importance in physics. For example, I have drawn this velocity time graph. If something is increasing with time, then there will be a graph. If it is something is decreasing with time, then there will be something different graph. So based on the graph, if we can understand what type of graph it is, we can find, okay, this is a straight line equation or it is something curved line equation. So corresponding mathematics can be developed, or vice versa. If you know the equation, you can develop into a graph. If the graph is known, you can develop into an equation. Both way it is very useful for physics. Now let us look into the next part. Circle and ellipse. Circle and ellipse. So what is a circle? Everyone knows what is a circle looks like. Circle looks like this, right? If you draw a circle, it looks like something like this. This is a circle. Right now, what is the equation of a circle? That is very interesting. For equation of a circle, we write x square plus y square equals to a square. If any equation can be written like this, then this represents a circle. Now if you see here, the power of x and y both are 2 and both has same value, same common. If there is a common, say suppose 2x 2y, is it a circle? Yes, it is a circle, because you can take 2 common, and divided it here, okay, and then you can rewrite this as a by root 2 whole square. So basically this is also a circle. So if the exponents are same, okay, and the powers are same, then we call it as a circle. Now what is the meaning of this a? What is the meaning of this a? This a represents the radius of the circle. So circle has a fixed radius. If the radius of the circle is a, then this is the equation. This is the equation for the circle. So you understood that circle has two things. Circle has two things. First of all, similar to the straight line, it has a equation that it obeys. The equation is in the power of 2 and x and y should have same exponent, and there should be a something in the square. Okay. Now next part is a parabola. Ellipse. What is an ellipse? Ellipse is almost similar to the circle. Ellipse is almost similar to the circle, but it's like an egg shaped. It's like an egg shaped. Okay. Symmetrical egg shaped, and instead of having same exponent, it has a different exponent. What is that? X square by a square plus y square by b square equals to 1. So if this a and b are equal, that is a circle. If a and b are not equal, then that is not a circle. So this distance is a, this distance is b. They have names that you will study in your mathematics class. I am not going to discuss semi major axis, semi minor axis. Just you should know the shape. This shape is called ellipse. Okay, instead of center of a circle they have focuses. They have focuses. Okay, focus F1, focus F2. Okay, and you will know that when you will study gravitation that all planets are orbiting around sun in a elliptical orbit. So basically you can consider this as a sun and we are orbiting in this path. Okay, that is our earth. So basically all the planets around sun are actually orbiting the sun in an elliptical orbit. Some are more elliptical, some are less elliptical. For example, earth is almost circle, not too much elliptical but almost circle. Some planets are almost very high eccentricity. So those terms you will learn in your mathematics class, but you should familiarize with this shape. This shape is called ellipse. Next shape that we are going to discuss, very important, is parabola. Parabola. What is the parabola? Parabola looks like this. Something like this. Not semicircle though. This is not a semicircle. This is a parabola. Parabola's equation looks like this. Y equals to ax square plus bx plus c. This is one type of equation. There is another type of equation. Now in most of the books the parabola is drawn like this. The parabola is drawn like this. Okay, plus and minus. But in physics, negative part we do not consider. Most of the cases we will only draw the positive part. Or there is another way of representing a parabola, that is this. Okay, so either this or you can write this as x equals to ay square plus bx plus c. Both are equation of parabola. Based on what you are writing, either it will be along this like this, y equals to, or it will be x equals to. So how they are changing, based on that you can write the equation of a parabola. And always we will only consider the positive part, that is this part. Okay, we will not consider this part because most of the cases if it is a time graph, time cannot be negative, so we cannot consider. Okay, time, negative time. So this part generally cancelled, not shown in the diagram. But this kind of U-shaped or like this V-shape, that ground shape, they are called parabola. And one of the very common example of parabola is projectile motion. You know projectile motion, in the when you were a child you used to throw that thing towards the birds or towards the fruits. Okay, that is a projectile motion. Or in nowadays when a rocket is launched from ground to another target, that is a parabola. So parabola, that is a projectile. So projectile is basically a parabola. There is a proof for first PU, those who have already completed their first year or class 11th, they know that trajectory of a parabola is a trajectory of a projectile is a parabola, right? So parabola, you have already completed parabola. It looks like this. This is a double parabola and the equation looks like this. Okay, next part is hyperbola. Hyperbola is very interesting. You already know the equation of ellipse, right? Ellipse looks like, equation for ellipse is x square plus a square plus y square plus b square equals to 1, right? Now instead of this, if the sign is minus, something interesting happens, and that structure is called hyperbola. So hyperbola looks like this. In positive axis it looks like this. Okay, but it has a negative part as well, and we do not consider the negative part. In mathematics you will learn the negative part, but in physics mostly we will only focus on positive part. Now what are the example of hyperbola? Common example is gas law, ideal gas law, PV equals to nRT or PV equals to constant. So PV equals to constant. Now if PV is constant, if you plot P along this direction and V along this direction, then the corresponding graph will be like this. The corresponding graph will look like this. There are few more examples for hyperbola, but most common example is PV equals to constant, or any case when you find x into y equals to constant, and if you plot x along x axis and y along y axis, then the graph will be a hyperbola. Okay, so hyperbola looks like this. Simple, everything looks simple. Next is something we are going to do is exponential decay. What is the meaning of exponential? Exponential is a term called e. Okay, it has a fixed value 2 point something. We are not interested in the exact value, but when we write something, for example, y equals to e to the power x, y equals to e to the power x, this is an exponential equation. This is an exponential equation. Okay, now there is a particular behavior of this function. There is a particular behavior of this function. There are two cases when it is increasing, another is decreasing. So for example, this equation y is equal to e to the power x, it is increasing with time, increasing with x basically. So if y increases with x, how can we say it is increasing? Because the sign here is positive. So if the sign here is positive, then we can say it is exponentially increasing and its graph will look like this. Okay, so basically it's like this, not like parabola. Parabola is more towards like this. Okay, parabola is more like bending, but it is going up. Okay, it is going up. So we can say it is exponentially increasing. Now there is another case where it is decreasing. How can I write another equation for exponentially decreasing? I can write exponentially decreasing simply by y equals to e to the power minus x. Okay, if it is like this, then it is called exponentially decreasing. Exponentially decreasing. So it will be like this. Its graph will be like this, and it will somewhat after some long time, long x, it will touch the x axis. Okay. So basically this is the another two things that you need to remember, that exponentially increasing is like this, exponentially decreasing is like this. Okay, and there's maybe sometime there is a constant. Okay, also there may be some constant here. That does not matter, as long as it is positive. Okay, it will be increasing graph. Now the degree of increase may be some increase like this, some increase like this, some increase like this. So that will depend on the factors that is involved. Or similarly, it is decreasing like this or decreasing like this or decreasing like this, that depends on these factors. But if it is a minus, it will always decrease. If it is a plus, it will always increase. Okay, that does not change. Okay, now let's look into the next part. Next part is slope of a graph. Slope of a graph. What is the meaning of slope of a graph? We will discuss a little bit more in the upcoming chapter, geometry. Slope means, as I already explained, in a straight line y is equal to mx plus c, is this m is called slope. Okay, and that slope basically means the angle whatever straight line is making, that angle theta, and if we take tan of that angle, that is called the slope. That is the basic meaning of slope for now. Now if this is not a straight line, we have learned so many graphs, right? So if this is not a straight line, what will happen? Suppose it is a graph like this. Now if I want to calculate slope, how can we calculate slope? Someone will say, sir, I will make this tangent here and I will make this angle. Okay, correct, but what about this point? If I draw a tangent from here, it will give me a different angle. So this slope actually varies from point to point if this is not a straight line. If this is not a straight line, then this angle varies from point to point, and for each point, suppose I want to find slope here, I will draw a tangent. I will draw a tangent at this point. Okay, and then I can do two things. Either I can extend it back to x axis, I can extend it back to x axis and measure the angle and calculate the tan theta for this point, or I can construct a small triangle. I can construct a small triangle, and let us say this is delta y and this is delta x. Then we can write that slope at this point is given by delta y by delta x. Simple. Why? because tan theta is perpendicular by base, right. So, perpendicular by base, if this angle is theta, this angle will also be theta. So, we can write perpendicular by base as slope, and it is for different points. For each point we can calculate the slope. Okay, for this point also I can calculate the slope, for this point also I can calculate the slope, and there are conditions based on how the slope is changing. We can say there are two different cases. One is increasing slope, another one is decreasing slope. So, for example, if I say there is a graph is like this. Now, can you tell me whether the slope is increasing or slope is decreasing? So, for that I have to draw a triangle here, okay, and I will see that angle is small. The same triangle if I draw here, okay, same triangle if I draw here, then it will be, you will see that angle is much bigger. If you measure this angle and this angle, this is bigger. So, basically what we can say, in this case the slope is increasing. So, sometime they will ask you draw a velocity time graph where velocity is increasing. So, velocity increasing means its slope will increase. Okay, distance time graph slope is velocity. So, distance time graph velocity increasing means this will be the graph for velocity increasing. Now, decreasing, slope is decreasing. Many people think if I draw a graph like this, it will be decreasing, because it is decreasing. Not necessarily, in some cases maybe it is not decreasing so easily. So, decreasing means slope is decreasing. Okay, remember that slope is decreasing. So, if I draw a graph like this, in this case if you see at this point, if you draw a triangle, whatever value you will get, and if you draw a triangle here, for the same value delta y will be very less. So, we can say at this point the slope, this is delta y and this is delta x. Okay, for same delta x, delta y is very high. So, at this point theta is very high as compared to this. So, we can say here the slope is decreasing. At this point the slope is decreasing compared to this point. So, basically slope is gradually decreasing as we are increasing the x. That is the point. So, slope of a graph can increase, slope of a graph can decrease based on the situation. So, if they say draw a graph and velocity is increasing, that means you have to draw distance time graph where slope is increasing. That means like this, velocity is increasing. Now, velocity means delta s by delta t, delta s by delta t, that is we already know in the differentiation terms that this is called velocity. Velocity is delta s by delta t, and this is basically the slope. So, if the velocity is increasing, that means slope is increasing. If velocity is decreasing, that means slope is decreasing, right. So, these are the basic terms. In some cases, in actual equations, if the equation is given, slope can be calculated by dy by dx. Those who have not seen my in calculus video, go in the comment below and check the calculus video where I have discussed in detail basic ideas about differentiation, basic ideas about integration. So, basically the slope is a differential of y with respect to x. Okay, here the x is t, y is s. So, ds by dt is basically your slope or velocity. Now, so there is an example, plot the xt graph for an object moving in uniform motion. So, xt graph means distance time graph, object moving in uniform motion. Simple example, very simple example, because this lecture is based on some first year students as well, those who have not done anything in their classes so far. So, if you are watching this for the first time, don't forget to click on the subscribe button. So, first year students as well, if you are struggling to understand physics in the lecture, whatever happening in the class, don't forget to watch this video, and the two parts that we have already covered and one more part that we are going to cover in our upcoming video. So, plot the xt graph of an object moving in uniform motion. So, xt graph, x means distance, okay, and time, t means time, okay, x means distance, t means time. So, xt graph of an object moving in uniform motion. What is the meaning of uniform motion? Uniform motion means its velocity is constant. Its velocity is constant, right? Uniform motion means velocity is constant. Now, how it will be? like many students will draw the graph like this. Okay, many students, okay, velocity is constant means x is also constant. Is it? So velocity constant, so car is moving with a constant velocity, its distance is constant. Is it static at that same point? It is only possible if velocity is 0. If this is the graph, that means velocity is 0. Object is not moving with respect to time. Object's position is not changing with time, that means this is the graph. No, velocity constant does not mean object is not moving. So velocity constant means its slope will be constant. Its slope will be constant. So it will be a straight line. So theta, I already said, for a straight line slope is constant. So theta is constant. So m will be tan theta, right? So any point if you draw the triangle, you will say, you will get same delta y for same delta x. So theta is constant. So this is a graph of object moving in uniform motion. Uniform motion means this. Now non-uniform motion, there are different types of motion that we are going to discuss in our chapter, motion in one dimension and motion in motion in two dimension as well. So don't miss those lectures. If you are watching this video for the first time, don't forget to click on the like button and subscribe button. Leave a comment below whatever doubts that you have, and if you have liked our video, please share with your friends. Thank you for watching this video. We will be back shortly with part 4 of basic mathematics of physics. Thank you.